CSIR-CECRI, Central Electrochemical Research Institute, is one of a chain of 38 national laboratories under the aegis of the Council of Scientific and Industrial Research (CSIR) in New Delhi. Founded on 25th of July 1948 at Karaikudi in Tamil Nadu, CSIR-CECRI came into existence in January 1953. During the last 50 years, CSIR-CECRI has been recognized as the premier institution for research and development in electrochemical science and technology, not only in India but also in Southeast Asia, with a total strength of over 600 personnel comprising of scientists, engineers, technologists, skilled workers, administrative and other staff, with a combined laboratory space of 400,000 square feet in a campus of 300 acres. There are 3 extension centers for CSIR-CECRI located at Chennai, Mandapam and Tuticorin.
It's a great honor and privilege for me to lead this Central Electrochemical Research Institute, an institution of national importance. This laboratory, from its inception, the laboratory has contributed significantly to the technological landscape of our country. In particular, Chlor Alkali industries, battery industries, corrosion mitigation technologies, electrochemical generation of many materials, and also gold plating. Many of these technologies would not have been possible to develop in our country without the contribution of this laboratory. Of late, with the new government policies, where we are supposed to strengthen our interaction with industries, we have made many changes in the system. What is more important is, we also have a fully automated system. Our response with respect to industrial inquiry is very fast. And consequently, many multinational companies, including Boeing Corporation from US, Colgate-Palmolive from US, they have all come to Central Electrochemical Research Institute looking for solutions for their challenging global problems.
Biocorrosion. India is a country surrounded by sea in all the 3 sides, and the sea is filled with very salty water and a lot of microorganisms, leading to biocorrosion. Biocorrosion happens on all scales. It happens, for example, in ships, which are usually in contact with water. However, to protect ships, there is another solution, such as cathodic protection, and CSIR-CECRI has rendered lot of consultancy services on cathodic protection. This technique was successfully used to solve various corrosion problems in the Cochin shipyard. Mandapam is a tip of land projection in the Bay of Bengal, wherein the southern side of Gulf of Mannar and northern side of Pak Bay. As early as 1965, CSIR-CECRI has established its atmospheric field exposure station at the Hillock site. This site is also proudly called as one of the most aggressive environment in the world in terms of the tropical marine atmospheric corrosion of metals and alloys. The full-fledged center of CSIR-CECRI has been established in the present location during 1975. Another major issue is concrete corrosion. CSIR-CECRI does elaborate research on the various objectives to prevent or minimize the corrosion of reinforcement bars. In order to monitor the strength and corrosion rate of a concrete structure, CSIR-CECRI has developed an integrated corrosion monitoring sensor (ICMS) gadget accessible through a mobile app. Another unique concept called triboluminescence, wherein CSIR-CECRI developed TL paint upon physical, chemical and mechanical stress would give away a fluorescent signal, which in turn would be captured by a custom-designed smart camera, and the image processed signal would reach either your mobile or your laptop when it is facilitated through IoT, Internet of Things. When we talk about the preventive measures against corrosion Obviously, one cannot ignore the role of paints and surface coatings. Old paints are to be carefully removed from the surface before a new paint is applied, and for the easy removal of paints, CSIR-CECRI has developed a neutral paint remover jelly. One of the unique achievements of the Paints Lab is the development of super hydrophobic coatings. These coatings contain very small structures on the surface having an element called fluorine, which repels water when it comes close by, much like a lotus leaf. Another type of coating that we have developed is the self-healing paint. When a surface covered with these paints is damaged or scratched, it has the ability to cure by itself, which is the interesting part of it. Similarly, CSIR-CECRI's 4-coat system for concrete structures, which has been given to more than 15 major paint industries such as Fosroc Chemicals, Asian Paints. Unlike paints, we have some chemical compounds with interesting properties that can prevent corrosion to a large extent. These are called corrosion inhibitors. Green corrosion inhibitors is one of CSIR-CECRI's recent products. This is biodegradable, non-toxic, and its corrosion inhibition efficiency has been tested in static and dynamic conditions. Bharat Petroleum Corporation Limited expedites CSIR-CECRI's consultancy service to study the causes of corrosion in its underwater oil pipelines. Electroplating is one of the surface engineering technologies for many applications such as corrosion resistance coating, decorative coatings, functional coatings, and electronic coatings. To brief about the existing technologies, we have proven expertise in areas such as electroplating of chromium, brush plating, barrel electropolishing, copper, anodizing, and hard anodizing. Electropolishing technology provides shiny appearance and good corrosion resistance for these stainless steel articles, and this technology is transferred to many industries. CSIR-CECRI has expertise on electroforming of larger sized materials like cryogenic rocket engine thrust chambers, steering engines, linear accelerators, waveguides, holograms, nickel crucibles, molds, and dies, which are used by ISRO, Indian Space Research Organization, for rocket parts. During the takeoff and landing, the landing gears of the plane experience a huge friction and wear and tear. To make the system more durable, these rods are electroplated with hard chrome. CSIR-CECRI has developed electroplating of chromium from both hexavalent and trivalent bars. Generally, nickel plating is used for corrosion resistance application in automotive industries, undercoating for high hardness materials, interconnects, etc. These are some common anodized materials used in our day-to-day life. Anodizing process can also be used for aesthetic applications. These are some parts prepared with anodizing followed by coloring process. Brush plating is useful for repairing of plated components and big objects where we need huge plating tank volume. Electroplating of gold. CSIR-CECRI developed the process and plated momentum wheel parts for the satellite is being used by ISRO. CSIR-CECRI thus ensures its contribution to strategic sectors and socio-economic developmental icons. Electrochemical power sources, ECPS. We all know that energy can neither be created nor be destroyed, but one form of energy can be converted into another form of energy, and this is where CSIR-CECRI's chemical energy to electrical energy conversion and storage efforts comes to limelight. For e-mobility and e-gadgets, we have the indispensable choice of lithium batteries only for the time being. In a step towards self-reliance and under our PM's Make in India program, we have installed India's first pilot prototype lithium-ion fabrications facility in CECRI Chennai unit. A program called Tap Sun Technology and Products with Sun Utilization Network has been started in 2011, where CSIR-CECRI spearheaded the Store Solar component. CECRI, Chennai unit. Recent success story includes demonstration of high-temperature air-cooled stack to TVS Motors, Hosur, development of 3 kW water-cooled PEMFC stack and validation in Patolganga site of Reliance Industries Private Limited, Mumbai, and 1 kW air-cooled PEMFC stack to IGCAR, Kalpakkam, many membrane electrode assemblies, MEA, of different area and its process parameters are optimized at CECRI Madras unit through different forms of decal, spray and brush coating. The best optimized version of MEA for its testing at the single cell level is done initially to benchmark the performance criteria. CECRI Madras unit has sophisticated electrochemical characterization facilities for basic research to understand the catalytic activity of the electrocatalyst, ionic conductivity of the membranes, and fuel cell test station and assembly units for testing cells and stacks of various capacities. CECRI is also working on indigenous zinc bromide redox flow battery with a target capacity of 500 watts. This is for the grid-level storage of energy harnessed from solar and wind energy. Towards testing of batteries, CECRI has created NABL accredited CSIR BP Tech Battery Performance Testing and Evaluation Center in 2014, a unique facility for assisting battery industries in quality management. Solar energy can be stored in batteries or in the form of H2 by splitting water. CSIR-CECRI has been involved in R&D program on PEM-based water electrolyzer to produce pure hydrogen and oxygen. Most of water samples collected near industrial hubs, especially, are found to contain toxic elements like fluoride, arsenic, etc. When such a water is consumed, obviously the consequences are alarming due to hazardous components. CSIR-CECRI has developed electrochemical deflorinator, dearsenator and electrochlorinator. The electrochemical deflorinator consists of electrolyzer, settling tank and filter. This reduces the fluoride from any level to 1.0 ppm. This technology was transferred to various clients in India. CECRI, in one of its attempts to mitigate water pollution using electrochemical techniques, deserves a special mention. To strengthen the hands of agricultural research initiatives through electrochemistry, here comes CECRI's attempts to launch a NPK sensor, which is an indicator to proceed further. Modern agriculture requires technology which can afford rapid and sensitive analysis of soil fertility. This particular development is expected to bring a huge societal impact. Another important area is about the waste-to-wealth driven electrodes. For example, food waste could be converted into electricity by microbial fuel cells, MFCs. The power output obtained from our MFCs is sufficient for running digital clocks, lighting low-power LEDs, and powering calculators. CSIR-CECRI has developed a number of electro-organic processes such as electrochemical oxidation of glucose to calcium gluconate, salicylic acid to salicylaldehyde, toluene, as well as substituted toluenes to corresponding benzaldehydes, electrochemical perfluorination, ECPF. At present, CSIR-CECRI is the only laboratory in the country having ECPF facility. We do have a technology on dyeing of cotton fabrics. Vat dye is the most popular among dye classes used for coloration of cotton fabrics, particularly when high fastness standards are required to light washing and chlorine bleaching. Further, we have developed 5-compartment membrane electrochemical process for the removal of chlorides from amino acids salt mixtures and chlorides from diamine hydrochlorides. To our credit, we have developed an electrochemical process for the preparation of D-arabinose with the yield of 85%, an important intermediate involved in the synthetic route of vitamin B2. Thermal barrier coatings, TBCs, find vast applications in the field of space, defense, and aerospace sectors. CSIR-CECRI is developing multi-layered TBCs using electroplating and plasma spray process. Functional materials, we do work on the computational materials science for simulation and modeling of battery materials, nanostructures, fuel cell catalysts, etc. Our contributions to develop supercapacitors are like this. Further, our contribution includes R&D on photocatalytic hydrogen evolution, wherein we work on the development of core shell nanoparticles for photocatalysis. The production of the gas hydrogen is confirmed using chromatography. Our scientists contribute to surface engineering for device applications under which thin films of transparent conducting oxides, transition metal nitrides, and bioceramics are being developed. 3D metal printing technology is used to fabricate custom-made metallic bone and dental implants with nanotopographies for faster osseointegration. Biomaterials Group. In India, medical device manufacturer in orthopedic and dental field are very limited. Most of the surgeons have to depend on imported implants which are very expensive for a common man. Our group mainly focuses on the development of bioactive, antibacterial and cytocompatible ceramic and metallic medical devices. Messrs. Colgate-Palmolive, USA, which is considered as one among the prestigious foreign projects that CSIR-CECRI has achieved. Chlor Alkali Technology of CSIR, Central Electrochemical Research Institute, has a special mention in the history of CECRI. As we all know, Chlor Alkali industry is one of the largest electrochemical industries that produces caustic soda, chlorine, and hydrogen. The major capabilities of CECRI in this area are development and commercialization of titanium substrate insoluble anodes, TSIA, to replace graphite anodes, coated anodes, and coated cathodes used in membrane cells for chlor alkali production. Today, we are working on the next generation chlor alkali technology, which involves oxygen depolarized gas diffusion cathode called ODGDC. Indian chlor alkali industry can save 1,800 million kilowatts of electrical energy per annum if all the caustic is to be produced from ODGDC fitted membrane cell. Yet another legacy is our CPCC technology, cement polymer composite coating, that has been transferred to number of clients and is being widely used across the country. Pamban Bridge is our pride proof of this technology. You were watching the glimpse of research activities of CECRI, the research institute where lights are not put off and labs are never closed, because researchers of all age groups work throughout the day and night, and solutions are being offered to very many challenging and alarming issues of this society using electrochemical techniques. To experience CECRI, do visit us in person and feel the joy of being with the scientists and researchers of this globally renowned unique institution. Whenever you have critical issues related to energy, corrosion, metal finishing, sensors, and electro-organic synthesis, do not hesitate to contact us. The head, Technology Transfer and Business Development, CSIR-CECRI, Karaikudi 630003, to get a one-stop, end-to-end solution. Yes, we do offer timely service, very much in line with the corporate business model, to help our clients in getting immediate and sustainable solutions. Our ably managed administrative support system and the team of innovative scientists are available 24/7 to our valuable customers, collaborators, and funding agencies. CECRI, the ultimate electrochemical solution provider.